something outran the stars over Mars. In October 2025, a streak of light, cutting through the Martian sky, moved faster than anything the red planet had ever seen. 60 kilometers, silent, precise, and deliberate. For a few seconds, NASA's Perseverance rover caught it in the distance before its night sky cameras went dark. Then, without warning, every orbiter monitoring the flyby of 3 Atlas, the mysterious interstellar visitor, stopped transmitting raw data. The silence was immediate, the timing impossible to ignore. When the first unofficial frames leaked, showing a faint emerald flash just above the horizon, the scientific world froze. No comet should move like that, and no ordinary object should glow without a trace of carbon or water vapor. Something had happened in those missing frames. Something no one at NASA, ESA, or even the James Webb telescope was ready to explain. And what the next images revealed would change everything we thought we knew about interstellar visitors. It began with a single amateur astronomer, Stephan Burns, who posted a 9-minute time-lapse stitched from Perseverance's public image archive. The sequence showed a razor-thin streak slicing across the Martian sky, moving at 60 kilometers, far beyond the speed of any known meteor or artifact. The alignment matched perfectly with the predicted path of 3 Atlas during its closest approach. Within hours, the footage went viral. Analysts across the globe rushed to verify or debunk it, stacking frames, cross-referencing timestamps, and comparing star catalogs. Some confirmed the streak. Others dismissed it as noise, but one anomaly kept returning. A faint green flash captured at exactly 4:03 UTC, too bright, too sharp, and too synchronized to be a glitch. The debate fractured into chaos. Was it a chemical emission, a cosmic ray, or something that Perseverance had caught only for a heartbeat? Something deliberately moving through the Martian night? As speculation grew, one question echoed through observatories and control rooms alike. If this was truly 3 Atlas, then why had every official data channel gone silent at that exact moment? Normally, Mars orbiter data floods public archives within days. This time, nothing came. The Mars Reconnaissance Orbiter, the Trace Gas Orbiter, and Mars Express, all confirmed to have observed the flyby, went completely quiet. No raw images, no preliminary calibration files, no telemetry, only vague statements about ongoing data verification. Inside JPL, imaging teams worked under intense scrutiny. For a target moving at interstellar velocity, even a fraction of a pixel's error could fabricate false fragments or phantom jets. Every image had to be hand-checked, every cosmic ray strike manually flagged. But the real reason for the delay was far stranger. Internal memos later revealed that multiple instruments had recorded objects near 3 Atlas that appeared to move in perfect synchronization, small faint companions trailing behind it in tight formation. The motion wasn't random. The geometry was precise. Some engineers called them debris fields. Others whispered another word: probes. As the Mars data backlog deepened, the only telescope still watching was the James Webb, waiting for the moment the interstellar visitor emerged from Mars's shadow. When partial spectral readings finally reached Earth, they deepened the mystery instead of solving it. Normally, a comet's green glow is the signature of dicarbon, molecules of C2 excited by sunlight. But the spectral fingerprint from Mars orbiters told a different story. There was no dicarbon. Instead, the data showed abnormally high levels of carbon dioxide, nickel, and cyanogen, a chemical blend no comet in our solar system has ever displayed. Even more perplexing was the ratio of nickel to iron, reversed, with nickel dominating by an order of magnitude. Planetary chemists tried to fit the readings into existing models and failed. Some suggested exotic formation zones in interstellar space. Others proposed contamination from unknown alloys. But the green glow remained unexplained. How could light behave as though carbon was burning when the carbon wasn't there? It was a paradox that defied every known rule of cometary physics. Unless the glow itself wasn't chemical at all. Unless it was something else. A signal masquerading as light. Then came the images that broke the model completely. Mars Express and the Trace Gas Orbiter both recorded something that no comet should ever produce. A jet of material blasting toward the sun, not away from it. A forward jet. Dust models collapsed under the data. The jet structure was too narrow. its brightness gradient too steep, and its geometry too perfect. It was as though the object was propelling itself rather than reacting to solar heat. Worse, despite the visible outgassing, 3 Atlas's trajectory didn't change at all. Its path remained gravitationally perfect, showing no measurable deviation from its predicted course. That meant one thing: whatever it was ejecting wasn't pushing it off balance. The object was too dense, too massive, too stable. Calculations placed its mass at more than 10 billion tons, far heavier than any known comet, and more akin to a metallic asteroid. As the data poured in, the term natural object began to crumble. What if 3 Atlas wasn't shedding dust at all? What if it was activating? As 3 Atlas disappeared behind Mars, a strange phenomenon gripped the deep space network. Engineers monitoring communications from the Martian orbiters began detecting interference, rhythmic pulses embedded deep within the signal noise. At first, they assumed it was an echo caused by solar wind or a frequency overlap from the comet's charged tail, but the rhythm was too consistent, too deliberate. Every 22 seconds, a faint spike repeated across multiple channels, identical on both NASA's and ESA's receivers. It wasn't strong enough to be a transmission, but it wasn't random either. The pattern seemed to mirror the comet's orbital motion, as if the object were responding to its own trajectory. Then, just as suddenly as it appeared, the interference vanished. Mission Control described it as electromagnetic resonance. Others called it a hum. But those who listened to the filtered playback described something far more unnerving: a low, mechanical vibration that seemed to accelerate slightly before cutting to dead silence. That was when the James Webb telescope, positioned millions of kilometers away at Lagrange 2, turned its instruments directly toward the region of space where the signal had originated. When the first long-exposure images from the James Webb telescope arrived, scientists expected the usual: a faint, blurred shape, maybe some faint dust trails left behind the comet. What they saw instead left even the most stoic astronomers speechless. The infrared data showed 3 distinct thermal signatures, not one. The first, an elongated core, matched 3 Atlas's expected position. The second and third, smaller and cooler, flanked the primary nucleus at equal distances. They moved in perfect formation, adjusting position slightly in correlation with Mars's magnetic field. The symmetry was unnatural, almost engineered. When color composites were rendered, faint arcs of ionized material appeared, connecting the 3 points, filaments that flickered like electrical currents. In visible light, the glow was faint green, but in infrared, the objects pulsed red-hot in exact synchronization with the 22-second frequency earlier detected in radio data. No comet had ever exhibited behavior like this. To some, it looked like controlled stabilization. To others, like propulsion. And yet none of the objects appeared to be accelerating. They were holding position, as though orbiting something unseen. Webb's spectrograph soon revealed an even deeper enigma: the presence of pure nickel vapor, metallic atoms heated to extreme temperatures, existing in quantities far exceeding what any natural body could produce. Nickel, dense and unyielding, should not vaporize this close to Mars, and yet its spectral line dominated the readings. Alongside it were trace elements of cobalt and an unknown compound, emitting faint but perfectly spaced emission peaks, too evenly structured to be random. The data resembled the harmonic pattern of a technological process, not a geological one. It was as if the object was refining itself, reorganizing its surface composition under the heat of the sun. Planetary scientists proposed wild hypotheses, from metallic crystallization to magnetic shielding, but none could explain why 3 Atlas's light was modulating in ways consistent with encoded data. The object's brightness was no longer constant. It was blinking like a beacon,